Okay, so let's get started. So today we're going to look into understanding principle of computer programming. So we have already in the previous tutorial we introduced basic all the fundamentals of programming languages with Java, where we stated what constant variables. We moved into more data types and data structure, and then we explained what are objects, what is object-oriented programming. So this is pretty much a really good introduction to programming, where now we're going to look into what are APIs. So by API, we are going to identify an application programming interface. So by this interface, we can now understand that is simply a simple program that's been built by us, which has the functionality to interact with our clients and our backend server user. So with this API, we're now able to retrieve or create, for example, we can retrieve, create, delete, update information by simply having our program able to connect to our client and then retrieve the information and then output a response. So as you can see, an API makes it easier for developers to work on a project where we can create this block of programming and then we can now manipulate them. We can now use this code to, based on what is going to be, based on what we're going to do with this, with our request. I mean, the example of maybe we just need to retrieve some data or we just need to update. For example, we have like a student, a college system management. We just need to update some student information or just, for example, delete or retrieve. That's where our API comes into place and it start working. So an API might be for a web-based system, operation system, database system, computer hardware, or software library. So I just made this example of a college management system where we do have all this information related to our student, and our API comes into place to allow us to retrieve or modify this data. So the documentation for the API is usually provided to facilitate usage. So normally once a program has been written by one developer, due to the fact that it is going to be handed out to all the people within the organization, it's really important to document the program by adding comments in order for us to understand what this piece of code is able to do. And also an API helps the developer to think less on the data or concentrate more on the app development on front end. So by having this good functionality, our developers nowadays they don't have to build anything from scratch because this API, this package has been written by other people within the organization, and you can now finally work with him. So an API specification can be in different type of forms, which will include some data structure, which we have already mentioned in the previous tutorial, might contain object or classes, variables or remote codes. So this API, they do have all the functionality of the programming, the basic programming that we have explained in the previous lecture, and they might be written in a different programming language depending on what is the nature of the business. So now we also have to look into what are the needs, the real purpose of using APIs as well, which consider a situation where we want to retrieve some data, as I explained, and now we can pull this information by running these commands. Also, other technologies that can integrate APIs. We can find this API on cost CMS softwares, for example, or we might have specific softwares which works with APIs. So, for example, here we do have a list of major active open APIs, which allows us to enable application to interact with each other. So this is a couple of examples, such as Open Cloud Computing Interface APIs, Fish Finance Data API, NFLRS API, and such on. So each of these software have been obviously designed for companies to work on these applications that have the main purpose to interact with our end user and retrieve data. So when it comes to evaluate the usability of this, when it comes to evaluate the evaluation of API, there are different factors, criteria that has to be taken into consideration. So for us to understand that we do have a really useful and scalable API, we now look into a couple of criteria such as security, functionality, usability, and such on. So as we can see, there are different type of APIs that can be provided. They could be license type. So by license type, this means that they're private. So by being private, we do need to own the key, or we have a signature for us to use this API. So for example, a simple example could be like when you purchase a Microsoft Office package, Outlook package, where is not an open source, and we know you have to pay for Microsoft Office. That's why you, for example, you make your £100 purchase, and it comes with a license. And once you do an installation, you have to enter the key in, which is normally 16 or 24-digit code. Once you have this license, you're able now to work with these APIs. This is a private API, and then we have open source programs, which are normally public applications where developers around the world can access them and use these softwares, these programs, which are available to everyone. So as we can see, API code generation. So the main goal of this research was to find tools that could automate the process of designing APIs. As we can see, all these programs have their own purpose. When it comes to request response model an endpoint, data formats and types of protocol to work with, JSON, REST, were also under consideration. So as I mentioned before, with by us being able to retrieve information and output them is where we're working with request response model. So by request response model, we just explaining an architecture. This architecture is simply the way this information is exchanged. So when it comes to creating, for example, dynamic website, we'll be working with JSON files. These JSON files are basically an architecture where it allows us to work with a CRUD, which is create, retrieve, update, and delete, as I explained. And this CRUD is all, these are all components of our request and response model. And also we have REST API or RESTful API, which we will touch more in detail once we run a video, which will quickly explain how RESTful APIs are structured and how they have to be used to develop develop websites. Also, we have to look into data storage, where we should support a NoSQL database or even a structured query language database. Now we're going also to understand other type of service, such as availability as a service. So this means that we have the ability to test and produce standards using them. Hello, Adrian.
Hello.
Yeah, I had a problem with my. I need to change this laptop, honestly, because there's a problem with the battery. It keeps going on and off. Yeah, I'm sorry. I'm sorry about that.
It's all right.
Let me just check if we are still live on YouTube. I don't know. Oh yeah, we're still live. Share my screen. Can you see my screen?
Yeah.
Okay. So where were we? We stopped. Oh yeah, we were looking into availability as a server. So as you can see, programming language, when we have a project Java-based, our tools under the consideration has to have this support. So it has to be having availability as a server. where we have the ability to test the product, our program, stateless process, where the implementation of our program has to be on a high level of scalability. Authentication and authorization, which allows us to support for popular standards, and monitoring, which will be really good for debugging. And at the end, we have scalability, which is basically the option to choose solution that should run on multiple instances. So I think we've touched into software development life cycle already, which is simply the process of the process of initial phase to end phase of a project, where we have multiple phases. We have initial, we have a planning, design, implementation, development, testing, maintenance, and that's how we have to conduct each single program. So with a system development cycle, it always referred to as the application development life cycle, which is used in system engineering and information system to process planning, creating, testing, and developing our information system. So what we need to understand is that this process will lead into the organizational formulation of a computing problem to execute computer programs. So each phase is really important, where we need to understand what are the different type of systems that can be integrated. So there are different types of systems such as agile, waterfall, and all of these systems, they require to be working with tools such as Scrum, Kanban, or many other tools to make the realization of the project the most effective. So we also have procedural programming, which is simply a programming paradigm where we just structure the program based upon the concept of procedural calls. So by procedural calls, also known as routine or subroutine, and functions, where we have mathematical functions but similar to those used in functional programming, where they simply contains a series of computational steps to be carried out. So by procedural is just following these given steps without looking back to what we've done, because each task has to be completed for us in order to be moving forward. Then we have functional programming. By functional programming is a programming paradigm where the style of building, the structure and element of computer programs that treats computation as the evaluation of mathematical functions and avoid changing state and mutable data. So by functional is simply has to be done with extension or declaration instead of statements. So we're just following some functions, some predefined programming steps, and not following a declared or statement functionality. So with functional code, an output value of a function depends only on the arguments that are passed into our function. So without us passing this value to our algorithms into our argument, these functions, the program will not be able to return the exact results. Also, by definition, functional programming has its own origin in lambda calculus, a formal system developed in the 1930s to investigate computability. The Entscheidung problem, functional definition, function application, and recursion. We already touched into object-oriented programming, where we already explained that our programs can be seen as object for us, in order for us to not repeat over and over again the same code. Where with this object we can now work with the major principles of object-oriented programming, which are encapsulation, abstraction, polymorphism, and so on. So a feature of object is that the object producer can access, often modify the data fields and the object with which they are associated. So once we look into our API, our program interface, we really need to structure it in a way that will be easier for us to retrieve this data and work with them. That's why it comes into object-oriented programming, to structure all our data in a way for us to find it easy to work with. So as significant object-oriented programming languages will include Java, C++, C Shell, Python, PHP, Ruby, and so on. Most of these programming languages, they all work with the concept of object-oriented programming, which has to be mastered for every developer in order for them to build and realize effective APIs. We already touched into what are variables and how these variables are used in our computer program, and how this value of our variable in our local storage can change at any time because it's not a fixed value. And we already explained that constant works in the opposite way, where we also give an example of how to define a constant in Java, which can be done with by declaring a final double and assigning a value. While for other programming languages, such as JavaScript, constant can be declared simply by using const, while a variable in Java is declared with integer, which stands for integer, while in JavaScript, we just simply use var as variable. So each programming language has pretty much the same concept, but they might come up with different keywords, but they do have the same meaning at the end of the day. So when it comes to programming language construct operators, we already spoke about talk about the operations that can be done. Construct which behave generally like functions, but which differ syntactically or semantically from a usual function. So we can now see some of these operations, such as logical operators and an OR, assignments, how we assign value. So for example, equal the symbol equal has a different meaning. When we assign the value equal, we just declaring. When we have double equal, means that that value has to be equal to the other value. So these are example of common simple operators, and most of them all these languages usually define a set of built-in operators, and in some cases they allow user-defined operators. So all these values do have their own. They do work with different meaning. For example, when we have a plus sign, we know that we are incrementing, while we have a comparison, which is the greater or less than, and they can also work combined. So we can put greater equal or less equal, which will work as an operator and will allow us to do some mathematical calculations. We already spoke about loops, where we just know that we are able to increment our values on our array by just assigning some operation to our loops, and we can therefore repeat our statement until we decide to break the loop. Well, we have already touched into if-else statement and what are the functionality, and this is everything. Is there any question for me?
No.
I hope this was clear, so we can look into a video which explains RESTful APIs.
Feel free to skip this video. So earlier at the beginning, RESTful services, also called RESTful APIs. If you already know what REST is all about, feel free to skip this video. So earlier at the beginning of the course, I introduced you to the client-server architecture. So most, if not all applications we use these days follow this architecture. The app itself is the client or the front-end part. Under the hood, it needs to talk to the server or the backend to get or save the data. This communication happens using the HTTP protocol, the same protocol that powers our web. So on the server, we expose a bunch of services that are accessible via the HTTP protocol. The client can then directly call these services by sending HTTP requests. Now, this is where REST comes into the picture. REST is short for Representational State Transfer. And I know it probably doesn't make any sense to you because it was introduced by a PhD student as part of his thesis. But the theory aside, REST is basically a convention for building these HTTP services. So we use simple HTTP protocol principles to provide support to create, read, update, and delete data. We refer to these operations altogether as CRUD operations. Now let's explore this convention using a real-world example. Let's say we have a company called Vidly for renting out movies. We have a client app where we manage the list of our customers. On the server, we should expose a service at an endpoint like this. So vidly.com/API/customers. So the client can send HTTP requests to this endpoint to talk to our service. Now, a few things about this endpoint you need to know. First of all, the address can start with HTTP or HTTPS. That depends on the application and its requirements. If you want the data to be exchanged on a secure channel, you would use HTTPS. After that, we have the domain of the application. Next, we have /API. This is not compulsory, but you see a lot of companies follow this convention to expose their RESTful services. they include the word API somewhere in the address. It can be after the domain, or it can be a subdomain like api.vidly.com. There is no hard and fast rule. After that, we have /customers, which refers to the collection of customers in our application. In the REST world, we refer to this part as a resource. We can expose our resources, such as customers, movies, rentals, on various endpoints. So this is our endpoint to work with the customers. All the operations around customers, such as creating a customer or updating a customer, would be done by sending an HTTP request to this endpoint. The type of the HTTP request determines the kind of the operation. So every HTTP request has what we call a verb or a method that determines its type or intention. Here are the standard HTTP methods. We have get for getting data, post for creating data, put for updating data, and delete for deleting data. Now let's explore each of these using our customers example. To get the list of all customers, we should send an HTTP GET request to this address. Note the plural name customers here. It indicates a list of customers. So when we send an HTTP GET request to this endpoint, our service should send us something like this. So we have an array of customer objects. If we want a single customer, we should include the ID of that customer in the address. Then our server would respond with a customer object like this. Now, to update a customer, we should send an HTTP put request to this endpoint. And note that again here, we're specifying the ID of the customer to be updated. But also, we should include the customer object in the body of the request. So this is a complete representation of the customer object with updated properties. We send this to the server, and the server updates the customer with the given ID according to these values. Similarly, to delete a customer, we should send an HTTP delete request to this endpoint. But here we don't need to include the customer object in the body of the request because all we need to delete a customer is an ID. And finally, to create a customer, we need to send an HTTP post request to this endpoint. Note that here, because we're adding a new customer, we're not dealing with a specific customer, so we don't have the ID in the address. We're working with the collection of customers, so we're posting a new customer to this collection. And that's why we should include the customer object in the body of the request. The server gets this object and creates the customer for us. So this is the RESTful convention. We expose our resources, such as customers, using a simple, meaningful address, and support various operations around them, such as creating or updating them, using standard HTTP methods. Hi guys, it's Mosh here. Thank you for watching my tutorial. I just wanted to let you know that this video is part of my upcoming Node course, where you will learn everything.
Okay, so this video gave a bit of example of RESTful API architecture, which is what we really need to understand about how API works and how important they are for us to work with data. So this is everything. Stop the recording.